step, crawling to the end of every word.
Okay, yesterday we talked about binomial theorem? No, we talked about Pascal's triangle yesterday. For 2 seconds, but you remember what I said about it?
Is that all with binomial theorem?
Well, the binomial theorem follows the pattern of Pascal's triangle.
Except math, more math.
Okay, so the reason why it's called the binomial theorem is it's a faster way to do a binomial expansion. How many people are up for expanding that? No. Right? Like, no one wants to do that old school way where we put it all out on a sheet and we start with the first two and then we multiply that product into the third one, right? So the binomial theorem allows us a faster way to do it, and it also allows us to pick out a specific term. Like I can say, what is the 15th term of this expansion? Okay, so that's what the binomial theorem does. It helps us do this faster. So the link to the Pascal's triangle is the coefficients in the binomial expansion follow this pattern. You two okay over there? Okay, so we talked a little bit about patterns yesterday, right? What's one pattern that we see? The ones. Every row starts with one and ends with one. So the middle numbers are increasing? Oh, okay, so this diagonal? The obvious one. How do we get to the next row? What do we start with? 1, and then what do we do? What's next? Add 4 and 1, so that gives us 5, and then what do we do? Add these two, which is 10. Add those two, which is also 10. This would be 5. And it'll finish with a 1. I didn't really follow the spacing, but you get the idea, right? So we know that we're adding things in the other rows. From the other rows, sorry. What else do we know? They're symmetrical. That's beautiful. And they follow kind of this odd-even pattern. First one has 1, second one has 2, third row has 3. How many terms does the fourth row have? 4. How many terms does the 17th row have? 17. It's almost like there's a pattern, right? So there's all these things that link it up, and you can solve it. You can solve it that way. Determine the sum for each horizontal row. Horizontal. What's the sum of the first row? Good job. What's the sum of the second row? Hopefully it's 2. What's the sum of... See a pattern? Yeah. Times it by 2. Powers of 2, right? We could say that that's 2 to the exponent 0, 2 to the exponent 1, 2 to the exponent 2. So Pascal had some time on his hands, and he found all these really cool patterns in this set of numbers. Okay, so each number in Pascal's triangle can be written as a combination using the combination formula, okay? Whereas n is the number of objects in the set and r is the number selected. You know that from yesterday's lesson. For example, you can express the third row. So here's the deal, is your row number minus 1 equals your n value. Yep, I'm recording. So if we're looking for the first row, or sorry, not the first row is kind of silly. If we're looking for the 10th row, we would start our combinations with n of 9. Okay? So let's express the fifth row using combination notation. So if it's a fifth row, what would we start with? 4. So it would be 4, choose 0. How many terms do we expect in the fifth row? 5. And then we'd have 4, choose 1. 4, choose 2. What? Hey! I'm recording a video, but I want to see the baby.
It'll be okay. Can you just finish that? Great. Combinations, good times. Welcome to Applied.
Yeah. He thought pre-cal was hard. Welcome to Applied. Yeah. Okay, so how many terms do I have in this one? 5. And why do I have 5 numbers instead of 4? Because what am I starting with? 0, right? So that adds the extra term there. So if you're looking, that's why you have to minus 1 from it, because we're starting with 0. 4, choose 0. What is that? 4, choose 0. Calculate that. So if you know this one's 1, what do you know about 4, choose 4? Did you have to do any math for that? No. You just had to know your Pascal's triangle, right? Yeah. 4, choose 1. 4. So what do you know 4, choose 3 is?
4. 6. Where's it 5?
12, 6.
Where's it 8?
Six. I didn't watch it.
It does say in the triangle 6, right? But you guys can all calculate that, right?
No.
Okay. All right. That gives me faith. Okay, we good? I can flip the page? Nothing crazy exciting there? Okay. We're going to expand this. We're going to do old school expansion. Old school expansion. What is x plus y to the exponent 0? 1. That one was good. What's x plus 1 to the exponent 1? Oh, brilliant.
X squared plus 2xy plus y squared.
Okay, so remember that you have to expand it and then multiply. Okay, so the next one, it's going to be x plus y times x plus y times x plus y. Are you guys okay with that blue pen? Can you see it okay? Yeah. All right. So it's the above one. Good catch. We know what the product of this one is, right? Yeah. It's from the answer above. So what's our next one?
X cubed plus 6x.
Okay. So x cubed. So we're multiplying x into here. Plus 2x squared y plus x y squared. And now we're going to take the y and we're multiplying it in here. So plus x squared y plus 2xy squared plus y cubed. So let's add that all up. Combine like terms. Oh, sorry, you guys can't even see the side of my page. So I've got plus 3x squared y plus 3xy squared plus y cubed. Okay, so that's a binomial expansion. So when we talk about binomial expansion, it's just taking a binomial and multiplying it x amount of times by itself. All right, so here's some characteristics. We're going to fill in the blanks. Okay, so what do you notice about that? Okay, so let's look at the number of terms. When my exponent is 0, how many terms do I have?
1.
When my exponent is 1, how many terms do I have?
2.
Okay, you see the pattern? It's 1 more than the exponent. So if n is my exponent, this is always going to be n plus 1. Okay, the first term, x to the exponent, n. So if this one was 3, the first term is going to be x cubed. So this would be x to the exponent n. And the last term? Okay, so these are the patterns that are going to happen, and we're going to see. The exponent of the first term begins with the same value as the
first term in the binomial.
Okay, so now I'm okay.
As first is Pascal, right?
Okay, the exponent of the first term begins with the same value as the exponent. And that's not a lot of room. And I meant to say the exponent of the binomial. Oh, can you not see that? Sorry.
But isn't that the same thing as point of thought?
Kind of, but this is, and what happens to them? So it's x cubed, and then where do I go next? Squared, and then where do I go next?
Squared.
And then 1, and then none. So what's happening? It is decreasing. So the first term starts with the exponent of the binomial, and it decreases. Decreases by 1 in each successive term. So that just means every next term. Okay, the exponent of the second term. Where is the first time we see y? What term does y show up in? Shows up in our second term. So, okay, and so here it's at 0, and then where am I? 1, and then 2. So this one's increasing. Okay, the sum of the exponents in each term always equals, what do these exponents add up to? The exponents. 3. What do these exponents add up to? What's this exponent? So what do they always add up to?
N.
They always add up to n. It's going to get a little bit more complicated, but we're going to start simple.
Why is this how we're ending the...
What? Who? What? It's going to get just a scooch.
Continue.
Okay. So, you know what? Maybe I'm not going to fill this in. This isn't going to make any sense. So just scratch that one out.
The terms are symmetric. Are same as there is in the...
It's the coefficient combinations is what I wanted there, but it doesn't really, we're just scratching it out. And what do you notice about, in your binomial expansion, the relationship to Pascal's triangle? Okay, so let's talk about coefficients. I'm going to switch colors here for a sec. What am I starting with?
1.
What are the coefficients here? 1 and 1. What are the coefficients here? 1, 2, 1. What are the coefficients here?
1, 3, 3, 1.
So they link to Pascal's triangle. So the coefficients on the binomial expansion are the ones, that's much better, are from Pascal's triangle. Okay, that's pretty cool. But I just want to point out that so this was the baby step. What's the coefficients on these ones? 1. So this is really nice. You see the pattern pop out at you. Guess what we're going to do?
No more ones.
We're probably going to do ones with different coefficients on them just to cause you grief.
Thank you for that.
Okay, so tell me what the coefficients for this one is. Okay, definitely we start with 1. Proud of you. What row are you in? Hold on. What's your exponent? 6. So I'm going to ask you again, what row are you in?
Oh my god.
Because number of rows minus 1 equals your n, right? Isn't that what we said on the last page? Still no. So what do we know? We know the exponent is, so we know n is 6. If I put 6 in here, and I want to isolate the number of rows, I'm going to add 1 to both sides. So what row are you in? 7. Okay, just wanted to throw that at you.
Thank you.
Okay, do the coefficients.
Is it 1, 6,
I don't know.
1, 56, 1?
What?
Yes.
Okay, so what do you start with? Your n still is 6, right? So it's going to be 6, choose 0, right? Which is 1. And then we have 6, choose 1, which is 6, thanks. 6, choose 2, 15.
But do you have to calculate that each time?
No, you can look at the Pascal triangle.
Well, we don't want to. I don't know how to do it.
6, choose 5. And 6, choose 6. What's 6, choose 6? 1. What's 6, choose 5?
6.
What's 6, choose 4?
15. 20.
She doesn't even have the button on her calculator. Madison's just back there, just whipping out the formula, easy peasy. You did your Pascal's triangle, right? Okay, so the next big part here is the binomial theorem, and all the patterns that we talked about is just expressed algebraically here. I think it looks really stressful, but it's not. What's your coefficient? What does your coefficient start with? Whatever your exponent is, and you choose 0. And what do you end with? N choose n, right? Okay. Thanks. Okay, let's do the first 3 terms. Okay. So all I want to see is the first, okay, so go back to this page for a sec. So you know how we did the binomial expansion of an exponent of 3? I'm asking you to tell me what term 1, term 2, and term 3 is. But this time I want you to do it with an exponent of 8, and we're going to use the binomial theorem to do it.
Okay.
Okay? Hold on to your hats, folks. It's going to be great. Yep. What do we know the coefficient of the first term is?
1.
So let's just do it as combinations. So it's going to be 8, choose 0. Yes, it will equal 1, but let's do it as a combination first. You're ahead of the game. We know that the first term in the binomial has the entire exponent on it. And we have no y's.
And then the n has the y.
Well, we did. And it's decreasing, right? In that first term, you only see the first term in the binomial. So what's our second term? No, still 8. Okay, so what happens to the x's? They decrease by 1. What happens to the y's? Increase by 1. Don't put brackets. Okay, good. I will never stop you from putting brackets. How many terms are going to be in this one? 9. You have 0. You have 0 in there. When you count on your fingers, what do you start at? We only want the first 3. We're not truth, and we're not ready to go all 8 yet, okay? X goes to 6 and Y goes to 2. And we're just going to say that it's going to come back like as a coefficient on the first term, yes. Okay, so Basil, can you evaluate 8, choose 0?
1.
Good job.
Period. See.
Are you sure? Yeah. Okay.
The third one is up to God, I don't know.
Okay, what's 8, choose 2?
20.
28? You think so? I like it.
So we have to use our calculators for the video?
I'm going to give you my black calculator for the exam so you can use the buttons on it. Okay, so notice I put the ellipses on after because there are more terms, we're just not calculating them. You guys know why I dropped the y here, right? Because it has a value of 1, so I don't need to write it. X's decrease while y's increase. All right, we ready? You need to remember the pattern.
It's got to be like negative now.
Okay. All right. We're going to expand the first 4 terms. How many terms do we anticipate if we did this whole binomial expansion? 15. 15. Okay, good. So, 14 choose? 0. First term is x, and it's going to be to the exponent 14. My second term, Danica, look at me using brackets.
Thank you.
I'm the slow learner. So notice because my second term is negative, I have to include that in there. Because that's going to change the pattern. Okay, so plus 14, choose 1. What does x change to? 13. What does negative y change to? 1. 14, choose 2. X goes to 12. Negative y goes to 2. 14, choose 3. X goes to 11. Negative y goes to 3. Oh, you guys. I was really spaced out, and now I have to take that room back. Okay, 14, choose 0. 1, good job. X to the exponent 14. Do I need to put that 1 there? No, I don't. But I'm going to do it anyways. Okay, so this is where things are going to get a little crazy, and I'm going to skip a step, and I'm going to get yelled at, but we're going to do it anyway. What's 14, choose 1? 14. Okay, no, I'm not going to skip a step.
Minus 14xy.
Yes, yes, okay. So this is going to be negative y. Well, it's negative y to the exponent 1. It's just negative y. 14, choose 1. Okay, so this is the thing with this term. So if I multiply that coefficient of negative 1 through, that's going to be x to the exponent 14 minus 14x to the exponent 13y. Okay? All right, so let's go on to the next term. So this is going to be 14, choose 2, 91. And negative y squared. is positive y. Okay, so do you see the pattern?
No.
Does anyone else see the pattern? Because odd exponents will keep this negative. Even exponents are going to make it positive. So what do you anticipate this term being? Negative. It should be negative, right? So what's 14 choose 3? 364. I am assuming that people are using their calculators. Yeah, like this would be on a calculator portion. And it will be on the calculator portion on your exam. There will be a binomial expansion question, for sure. 1,700 pages.
It's probably 17.
I'm going to say I don't know. Like, I give you lots of room to work.
I know.
Plus the graphs too. This whole year.
Okay. Yeah. So the more practice you do, the more likely you are to have seen that question. What? Probably not. And Basil's going to lose his mind because on the sine graphs and stuff, just a line. I'll see if I can find a better one. Okay, this is the one that, so you guys see the pattern with the positive negatives, right? Okay, here, the x has a coefficient. Do you guys not have this one? Okay, all right, let's go. We're going to expand the whole thing. How many terms are we going to have? 4 terms. So C, 3 choose 0. First term. So the 2x has to go in brackets to the exponent 3 and b to the exponent 0.
Does that mean the other question had 13 terms because of the minus?
It should have had 15 terms.
So that stays the same?
Yeah. Okay. We're just living on the edge here, Madison. Living on the edge, trying new things. Okay, then the next one's going to be 3 choose 1. What's happening to my 2x?
2x
Squared. B to the exponent 1. Oh, see, I'm getting spacey again, and I need to tighten things up. 3 exponent 2. 2x goes to
1.
hopefully 1.
Well, it's still nothing, but nothing.
Okay. B squared. And then the last term is going to be 3 choose 3. And you know you're done when you've maxed out. Like it's the n equals the r. And then you're going to have 2x to the exponent 0 and b to the exponent 3. Sorry. All right. So now we're going to evaluate this. This is where we're going. Well, we're expanding it because we're not done yet. So 3 choose 0 is 1.
But 6x.
How about 8?
Oh, 8. Wow. Math. It's hard. 2 times 2 times 2.
It does make a good point. That exponent has to apply to your coefficient and to your variable. That's where we forget it sometimes.
So 12x squared b. That's
Let's just do it in pieces, though. Okay, so what's 3 choose 1? 3. And then we're going to have 4x squared times b plus what's 3 choose 2?
I'm going to do it.
3. And then 2x.
Oh, yeah, the cube is just 1, 3, 2.
Yeah. And then 3 choose 3. 1. That goes away, and we are at b cubed. All right, so I've got 8x cubed plus 12x squared b plus 6xb squared plus b cubed. That's your full binomial expansion. You could have done it old school, ladies and gentlemen. You could have taken the terms and done what we did on that second page.
And maybe in like a smaller case like that, it doesn't work very well.
If you're, yeah, but I need you to be able to do it in something like this. And you can't do that without your binomial theorem. Okay. Okay. All right. This formula, ladies and gentlemen, is on your formula sheet. You ready? Okay. All right. You're not emotionally ready? That's what I just said. I said this is, I circled it and said this is on your formula sheet. And you followed up with, is this on my formula sheet? Okay. So it is. It's under logarithms. What? Okay, I'm going to stick with this formula because I'm pretty sure it's on the formula sheet. Oh, okay. Okay. All right. So K is always one less than the term that you're trying to find. Let me grab the formulas. Maybe we'll use the one on the formula sheet so nobody has a mental breakdown.
Well, because it says
Okay. So the one on the formula sheet is the term is K plus 1 equals NK AN minus K B K. Oh, sorry. All right. So let's get rid of this one. And we'll put that one in. You don't have to scribble the other one out. Okay, or go ahead and scribble the other one out. All right. So your K value is always one less than the term that you're trying to find. So if you're trying to find the seventh term, K is going to be 6. Everybody with me here? Yeah. So if I'm trying to find the seventh term, I would put 6 in here because 6 plus 1 is 7. Okay? All right. So we're going to find the fourth term. So what is K?
3.
K is 3? It is, yeah. No, because I was using the other formula, and so actually mine is a completely different question. So we're all good in the hood. Okay, so let's fill in what we know. We're going to find the term. So term 3 plus 1. You could write 4 in there, but I don't want to miss any steps. What is the total number exponent? No, it's 8 terms, but my n is 7. So 7, and then we are looking for K, which is 3. We are looking for the fourth term. Oh, sorry. Does that help, Amber? Like your A is your X, and your B is your Y. Okay. Okay, so it's going to be our first term, which is 2x, and then it's going to be n minus k, and then it's our second term, Just a negative y cubed. This is a tough question right off the hop. We're doing all the things in it, and it's going to be to k. So we know that the fourth term, what's 7 choose 3? 35. So 2x to the exponent 4 and negative y cubed cubed. Okay, what do you anticipate with the y? Is it going to be positive or negative? Negative. So we anticipate that the fourth term is going to be negative of this binomial expansion. Okay, so we have 35, 16, x to the exponent 4, and negative y to the exponent 9. You got to know exponent rules as well. Okay. We put it in the front. It's right there. It just moves to the front. Okay, what I would like you guys to do is I'd like you to do the next one on your own. Try it. Yeah, do it. Okay, you're finding your seventh term, so what's your K? 6. I'm having a hard time. And your the most outside exponent. What do you guys anticipate for the B? Is it going to be positive or negative? Positive.
I have a huge number this time.
Yeah, I have like 98 million.
Yep, you're good. Yep. Oh, geez, Louise. 98,513,415. A9, B12? Oh, it's, yeah, B12. Exponent laws, right?
No, I just put the wrong.
Okay, not terrible, but you really do have to slow down and take some time to think about what you're doing. I find as soon as I read the 7th, I go and put my K equals 6 right above it, just so that I know exactly what to do. n is your outermost exponent. Am I good to flip the page? All right. Here we go. So this is asking, it's not telling you to find the 10th term or the second term or anything like that. It's saying, tell me what term contains x to the exponent 15. What term has x to the exponent 15 in it? Is it the 10th term? Is it the 8th? How do you know it's the 5th? Right, but you're neglecting your second term. Good strategy, and that's exactly what I want you to do. I want you to figure out the pattern of what's happening with your x's. So what would be the first term? 10 choose 0. 10's my outer exponent. My first term always starts with choose 0. I don't know what the binomial thing is. No. Oh, sorry, it's not y. The second term is negative 2 over x squared to the exponent 0. So would you guys agree that term 1, do I really care? Like, I don't need to evaluate the other stuff. I'm looking for the pattern of what the exponents are. So term 1 is going to be 10 choose 0. This will be x to the exponent 30. Right? Everybody agree with me in term 1? So in term 2, 10 choose 1. I've got x to the exponent 3 to the exponent. What happens here? 9. It goes down by 1. What happens to the other exponent? It goes up by 1. So this one's going to contain x to the 27 over x to the exponent 2. Well, I guess it would have a negative and 2 in front of it, plus my 10 choose 1. I'm not calculating out the numbers. I'm actually just figuring out this. So this term is going to contain... What? What? Sorry, Madison. Finish your sentence. Wouldn't it be... It is the fourth term.
When you have an exponent that n equals 2, that times by 3 equals 2.
But you have the squared on the bottom. That's the same thing Pablo was saying. Like, this is 27. So you would have to go, if it's 4, right? You're just looking at that first term. But there's x's in the second term. Right? So you got to consider those. So in term 1, x is 30, or x to the exponent 30. In term 2, x is to the exponent 25. What do you think term 3 is happening? So term 3 is going to be 10 choose 2, x cubed. What's my exponent on the x cubed? It's 8 now. And then negative 2 over x squared to the exponent 2. So I'm just looking at my x's. So x, 24. So what's the pattern? Term 1 has 30. Term 2 has 25. So it goes down by 5 every time. So what term is going to contain x to the exponent 15? Term 4. You have to find the pattern. You got to show me how you got it and that you just didn't pull 4 out of the air and got lucky. Like, I need to see something. Now, you could do the full binomial expansion until you found it if you wanted to do that. That's a strategy to do that. Finding a pattern is a strategy to do that. There's lots of different ways to do it, but you got to show me something. Not just, oh, it's the fourth term. All right. Can you do this one? This one's a little bit easier. This one's a little bit easier because they're different. Find your pattern. Find your pattern with y's. What does the first term contain? Does the first term contain any y's? How many y's does the second term contain? Or what's the exponent on the y in the second term? It's the sixth term. Right? So what's the pattern? What do you start with the second binomial? So what's that? That has nothing in it. The second term would be, oh, sorry, I forgot my cubed. So this one will contain no y's. This one will be y to the exponent 3. This one will be y to the exponent 6. What's the next one? 9. What's the next one? What's the next one? So that had none. So what term contains y to the exponent 15 in it? 1, 2, 3, 4, 5, 6.
If I wanted like that misspelling, would you say that I found the pattern?
Yep.
Like you would give me marks for that?
Yep. So it's easier to do if the patterns make sense to you. If it doesn't, then do the expansion until you find it. You could work backwards. What would the exponent have to be? So if we had, what was it? Term k plus 1 equals c n k a to the n minus k. I feel like I've lost you guys. B to the exponent k. So there's another way you can do this. You can work backwards. What did we know? Like we're looking at that b term, right? And we know that b substituted was cubed. And we know we want it to equal 15. So what would we have to multiply 3 by? 5. So we know that that has to be 5 because we want it to get to 15. So knowing that information, you just solved for k. So your a value would be 2x. N is 12 minus k. Pardon? Oh, sorry, not 15. It would be 5 here. Yeah, because that would be the reverse, like of what we were talking about before, right? So this would be 12, 5, and we know that, so this would be 5 here, because we found k. So term 6. Got it? Great. That's it. Tomorrow you have a whole day work period before you do your test on Friday.